Sir Phil na nagsasabing, piliin mong matuto. Good day everyone, welcome to my YouTube channel. This is Sir Phil and this is Sir Phil's channel. Okay, so before we proceed with the lesson, because today we are going to learn another lesson in mathematics, I want to thank everyone who watched my first video. It was very successful, and also to those who subscribe, please continue to subscribe in this channel to learn more about mathematics. So before we proceed again, we're going to have our new lesson, but if you can still remember, we have a home task to be checked today in this video. So let us have first the checking of home task number 1. It is given with this. According to the direction, we're going to write the following quadratic equations in standard form and identify the values of A, B, and C. So I will reveal the answers right now, but before that, I want you to put the scores, your scores, on the comment section of this video after the checking. So I'll give you 90 seconds to check your work, and here are the answers. Okay, again, we can have 2 points for the quadratic equations itself, and then 1 point each for the value of A, B, and C. So for per item, we have 5 points. Overall, we have 25 points. Okay, so I'll give you 90 seconds to check your work, and your 90 seconds starts now. Okay, that's it. Okay, so if you're done checking, write the scores on the comment section of this video. Okay, so I'm now going to introduce you to our new lesson for today, which is the first method of solving quadratic equation. Okay, so today we're going to solve quadratic equations by extracting the square roots. This is the first method that I'm going to discuss throughout the video lessons. And we will start with the objectives. The first objective of this lesson is to identify the real and unreal solutions in quadratic equations. Second, of course, is to solve quadratic equations by extracting the square roots. Okay, are you ready? Okay, so let's start. Let's start quadratic equation in the form x squared equal to say. So as you can see here, we will be dealing with still quadratic equation, of course, and this time in the form x squared equal to k. So quadratic equation that can be written in the form x squared equal to k can be solved by applying the following properties. So we're going to discuss first three properties which involve the value of k in the quadratic equation in the form x squared equal to k. So the first property is that if k is greater than to 0. So if k is greater than to 0, then x squared equal to k has two real solutions or roots, and that is x equal to positive and negative square root of k. Let us have, for example, we are given x squared equal to 9. As you can see, x squared here is our quadratic term, and positive 9 here is the value of this variable k. So as you can see, positive 9 is greater than 0. So by the use of extracting, all we have to do is to get the square root of the both sides of the equation, so that we have square root of x squared equal to the square root of 9. So after that, by simplifying, we have x, the square root of x squared is x, equal to the square root of 9, which is positive and negative 3. So if we can observe, we have here two solutions, which is positive 3 and negative 3, which are considered as real solutions or roots. So we have 2, that is positive 3 and negative 3. So therefore, it has two real solutions or roots, which are 3 and negative 3. This is always happen when the value of k is greater than to 0. This is always true if the value of k is greater than to 0. So if the value of k is greater than to 0, we can conclude that the given quadratic equation has two real solutions or roots. Okay, so the second property will be if k is equal to 0. So if k is equal to 0, then x squared equal to k has one real solution or root, and that is x equal to 0. So let's have an example. We are given here r squared equal to 0. So do not be confused if from our different example we're going to use different variables. The most important here is that we still have the exponent of 2, which considered as a quadratic equation. So x squared here is represented by r squared. So r squared equal to 0, and 0 is the value of k. So again, if k is equal to 0, then it has only one real solution. So the same manner, we get the square root of both sides of the equation. That is simply equal to r equal to 0. So if the value of k is 0, you will get only one real solution or root, and that is 0. So therefore, it has one real solution or root, which is 0. So this always happen if the value of k is equal to 0. So going back from the two properties again, if k is greater than to 0, the quadratic equation has two real solutions or root. But then if k is equal to 0, so therefore we have only one real solution or root. Okay, the third property, what if k is less than 0? So if k is less than 0, then x squared equal to k has no real solutions or roots. Let's say, for example, we are given w squared equal to negative 9. W squared here will represent our quadratic term in the form x squared equal to k equal to negative 9. Negative 9 is the value of k. So because we are pertaining here the values of k which are less than 0. So those are the negative integers. So we have here now in the example w squared equal to negative 9. So we have to extract the square root, as you can see, we have the square root of double squared equal to square root of negative 9. So, pwede na tayo hindi mag-proceed dyan since hindi pwedeng magkaroon ng negative number inside the square root. So, we can already conclude if we have this particular example that it has no real solutions or roots. This only happens if the value of k is less than 2, 0. So going back again, if the value of k is greater than to 0, then therefore we have two real solutions or root. If k is equal to 0, then we have only one real solution. And if k is less than 0, so therefore we have it has no real solutions or roots. Okay, so by that, let us have first our fast mind exercise. So what we're going to do, I have here again 5 quadratic equations in the form of x squared equal to k. So what we're going to do, we need to identify the type of solution or solutions or roots that a given quadratic equation in the form x squared equal to k have. So this time we're just going to depend on the value of k. So again, let us review before we proceed. If the value of k is greater than to 0, so therefore we have two real roots or two real solutions. So if the value of k is greater than to 0, you just write it has two real solutions or roots, any of the two. And then if k is equal to 0, as if you can see on the given, so you will write it has no, if 0, it has one solution or root. And if the value of k is less than 0, if you can see on the given, so you write it has no solutions. Okay? So I will give you 30 seconds to answer this fast mind exercise, and your 30 seconds starts now. Okay, time is up. So let us now check your work. Okay, so again, if k is greater than 0, you write two real solutions. So if k is equal to 0, you write one real solution or roots. And then if k is less than to 0, so you write no real solution or roots. So these are the answers. Okay, so as you can see, the first given, we have x squared equal to 8. 8 is greater than to 0, so therefore we have two real solutions or roots. You can write any of these solutions or roots. Number 2, s squared equal to negative 3. Since negative 3 is less than 0, then it has no real solutions or roots. Number 3, we have m squared equal to 0. So since the value of k is 0, then therefore we have one solution or root. Next, we have the value of k, which is negative 1 in w squared equal to negative 1. It has no real solutions or roots since the value of k is less than 0. And then we have r squared equal to 12. As you can see, positive 12 is greater than to 0. So therefore, it has two real solutions or roots. Okay, on the next section of this lesson, we'll be dealing more of quadratic equations in the form of x squared equal to k. So this time we're going to solve different situations of quadratic equation still in the form of x squared equal to k. So are you ready? Okay, so now I'm going to introduce to you now the extracting the square root. So the method of solving quadratic equation in the form x squared equal to k is called extracting the square root. So particularly in this type of quadratic equation, we're going to use a particular method which is extracting the square roots. So let's us now have example number 1. So find the solutions of the quadratic equation x squared minus 25 equal to 0. So the first thing that we need to do here is to write the equation in the form x squared equal to k. Since we are given x squared minus 25 equal to 0, we need to eliminate negative 25 here. So to eliminate negative 25, we need to make this become 0. So to make this 0, we need to add 25. So that's why it became x squared minus 25 plus 25. Since we add positive 25 here, since this is an equality, we need to add also 25 on the other side of the equation. So negative 25 plus 25 here will now become 0. So matitira na lang is x squared equal to the right side we have 0 plus 25, and that is 25. So as we can see, x squared equal to 25 is now in the form x squared equal to k. So we are now ready to extract. So by that, we need to get the square root of both sides of the equation, and that is square root of x squared equal to the square root of 25. So simplifying the terms, we have square root of x squared, which is x, equal to the square root of 25, which is positive and negative 5. So if you notice, the value of k here is positive 25. Since this is greater than to 0, so therefore we could have two real solutions or roots, and that's why we solve positive and negative 5. So this is now our solution for the quadratic equation x squared minus 25 equal to 0. So to make sure, you can also check if the solutions positive 5 and negative 5 satisfies the equation. So this is already done to make sure if your answers are correct. So let's first deal with the solution x equal to 5. So all we have to do is to substitute positive 5 from the original equation, x squared minus 25 equal to 0. So by that, we use 5 as x. So that will become 5 quantity squared minus 25 equal to 0. So by simplifying, 5 squared is 5 times 5, and that is positive 25. Copy, minus 25 equal to 0. So if the left side and the right side of the equation became equal, so therefore positive 5 satisfies the given equation. So therefore, positive 5 is a solution. So 25 minus 25 is 0, equal to 0. So therefore, positive 5 is a correct solution. So let us now do the same process with x equal to negative 5. So again, we need to substitute negative 5 to the original equation, x squared minus 25 equal to 0. So that we have negative 25 quantity squared minus 25 equal to 0. So negative 5 squared is negative 5 times negative 5, which is equal to positive 25. And then you copy this, negative 25 equal to 0. So 25 minus 25 is 0 equal to 0. So therefore, negative 25 is also a correct solution for x squared minus 25 equal to 0. So you may not include checking on the solution. So checking is only used for you to make sure if the computed solutions are correct or satisfies the given conditions or the given quadratic equations. Okay, so let us now proceed with the next example. So therefore, from example number 1, the equation x squared minus 25 equal to 0 is true for x is equal to 5 and x equal to negative 5. And then it has two real solutions. Okay, proceed with example number 2. Find the solution of the quadratic equation 2s squared minus 72 equal to 0. So this time we're going to use the variable s for the quadra quadratic term. So again, we need to write the equation in the form x squared equal to k. So as you can see, we are given here 2s squared minus 72 equal to 0. So again, we need to eliminate negative 72 here. So to eliminate that, we need to add 72. So that will become copy 2s squared, copy minus 72, and then you add 72 to make this 0 equal to, since this is again an equality, if we add 72 here, we need to add another 72 to the other side of the equation. So negative 72 plus 72 here is now 0, so this will become 2s squared equal to 0 plus 72 is now 72. So again, we need to write the equation in the form x squared equal to k. So x squared here must not have a numerical coefficient. So if you can see on the given, we have here the numerical coefficient of the quadratic term, which is 2. So we need to eliminate this. So we need to use another property, which is the division property of equality. So to eliminate 2 here, we need to divide both sides of the equation by the numerical coefficient, which is 2. And that will become 2s squared divided by 2 equal to 72 divided by 2. So the 2 here will now become 1. So this will become s squared. And then we divide the right side of the equation, that is 72 divided by 2, which is 36. So now we have the resulting equation s squared equal to 36, which is now written in the form x squared equal to k. So now we are ready to extract. So get the square root of the both sides of the equation. We have the square root of s squared equal to square root of 36. So get the square root of s squared. We have s equal to the square root of 36, positive and negative 6. So therefore, the solution of the given equation 2s squared minus 72 equal to 0 is positive and negative 6. So let us now check if the computed roots or solution satisfies the original given, which is 2s squared minus 72 equal to 0. So we have s equal to 6 and s equal to negative 6. So let's start with checking if the value of s is positive 6. So again, we need to substitute the value of s6 to this original equation. So this will become 2, you copy 2, and then s now will become positive 6, quantity squared, minus 72 equal to 0. So we will start first with getting the simplified form of this 6 times 6, which is 36. So we have now 2 times 36 minus 72 equal to 0. So 2 times 36 is 72 minus 72 equal to 0. So 72 minus 72 is 0. So 0 is equal to 0. So the right side and the left side of the equation are now equal. So therefore, positive 6 is a solution for 2s squared minus 72 equal to 0. So let us now use our computed root, which is s equal to negative 6. Again, we substitute negative 6 for s. So again, we copy 2. S now will become negative 6, quantity squared minus 72 equal to 0. So simplify, negative 6 times negative 6 is again positive 36. So this will become 2 times 36 minus 72 equal to 0. So 2 times 36 here again is 72. Copy minus 72 equal to 0. So 72 minus 72 is again 0 equal to 0. So therefore, s equal to negative 6 is also a solution for the equation 2s squared minus 72 equal to 0. The equation 2s squared minus 72 equal to 0 is true for x equal to 6 and x is equal to negative 6, as you can see from the checking. So therefore, again, it has two real solutions. Okay, let us have a similar example. For example number 3. So in example number 3, we are given find the solutions of the quadratic equation 3x squared minus 48 equal to 0. So again, we need to write the equation in the form x squared equal to k. So by that, in this given, we need to eliminate first negative 48 and then later we're going to eliminate 3 as the numerical coefficient of the quadratic term. So to eliminate negative 48 first, we need to make this 0. So we need to add 48. So copy first the quadratic term, 3x squared, copy minus 48, and then you add 48. Again, this is an equality, so since you added 48 here, you add 48 also on the other side of the equation. So negative 48 plus 48 here is now 0. So this will remain 3x squared equal to 0 plus 48 is 48. Again, we have a numerical coefficient here for the quadratic term. So we need to divide or use the division property of equality by dividing both sides of the equation by the numerical coefficient, which is 3. So that will become 3x squared divided by 3 equal to 48 divided by 3. So the left side now will become only x squared since 3 divided by 3 is now only 1. So we have here x squared. And then we divide the right side. 48 divided by 3 is 16. So as you can see now, x squared equal to 16 is now in the form x squared equal to k. So we are now ready to extract. So by that, we get the square root of the both sides of the equation. That is the square root of x squared equal to the square root of 16. So the square root of x squared is x equal to the square root of 16, which is positive and negative 4. So therefore, the computed roots or the solutions for the given 3x squared minus 48 equal to 0 is positive and negative 4. Again, let us check if our answers are correct. So in 3x squared minus 48 equal to 0, which is the original given, we substitute x equal to 4 and x equal to negative 4. So by that, let's start first with positive 4. We're going to substitute this positive 4 to x here. 3x squared minus 48 equal to 0. So by substitution, we have copy 3, and then x now will become 4. Positive 4 quantity squared minus 48 equal to 0. So let's start with the exponents. 4 times 4 is 16. So we copy 3 times 16 minus 48 equal to 0. So 3 times 16 here is now 48, copy minus 48 equal to 0. So 48 minus 48 is 0 equal to 0. So therefore, x is equal to 4 is a solution for 3x squared minus 48 equal to 0. So let us now check for the value of x, which is negative 4. The same manner, we substitute negative 4 to x. So that will become 3 quantity negative 4 quantity squared minus 48 equal to 0. So again, we have this first, negative 4 times negative 4 is positive 16 also. So that will become the same, 3 quantity positive 16 minus 48 equal to 0. So 3 times 16 now is 48 minus 48 equal to 0. So 48 minus 48 equal to 0. And that is 0 equal to 0. Okay, so therefore, the equation 3x squared minus 48 equal to 0 is true for x is equal to 4 and x is equal to negative 4. So therefore, it has also two real solutions. So let's have first a short break. Okay, let us continue with the other condition for example number 4. So let's see the given. Find the solutions of the quadratic equation quantity x minus 2 quantity squared minus 9 equal to 0. So this is another conditions for quadratic equation in the form x squared equal to k. but we will still use the same process as we did from the first three examples. So the first thing that we need to do is to write the equation in the form x squared equal to k. So this time we are given this. So what we're going to do first is to eliminate negative 9 here. So to eliminate negative 9 here, we need to add again 9. So you copy first this whole term, quantity x minus 2 quantity squared, and then you copy negative 9 or minus 9. So you will make this 0, so you need to add 9. Again, this is an equality. Since you add 9 here, you add 9 also on the other side of the equation. That's why it became 0 plus 9. So you copy this again. Negative 9 plus 9 here is 0 na. So this will become quantity x minus 2 quantity squared equal to 9. So as you can see here, this particular given is already in the form x squared equal to k. Ang pinagkaiba lang, the whole x squared here, which is the quadratic term, is represented by a binomial. So this will become x minus 2 quantity squared equal to 9. So this particular condition is now ready for extracting. That will become the square root of quantity x minus 2 quantity squared equal to the square root of 9. So what will happen is if we get the square root of this, the exponent here will be eliminated. This will become now x minus 2 only. So as you can see, we just eliminated the exponent. So that will become x minus 2 equal to, and then we get the square root of 9, which is positive and negative 3. By that, we created x minus 2 equal to positive negative 3, two different linear equations. So we're going to solve two values of x. One is using positive 3, and then the other one is using negative 3. So as you can see here, we have two separate linear equation for the resulting equation, that is x sub 1, or the first value of x minus 2, just copy, equal to, you use first positive 3, and then the other value of x, which is x sub 2, you just copy that, or put 2 to represent that this is the second value of x. Copy again, minus 2 equal to, this time we use negative 3. So we're going to solve these two separately. So let us continue. So the first value is x sub 1 minus 2 equal to 3. And the second value is x sub 2 minus 2 equal to negative 3. So we need to solve for the first value of x. So to do that, we need to eliminate negative 2 here. So we need to add positive 2. So that is x sub 1 minus 2 plus 2. Since again, this is an equality, if we add 2 here, we add 2 to the other side. That's why it became x sub 1 minus 2 plus 2 equal to 3 plus 2. So negative 2 and positive 2 here will now become 0. So that will become x sub 1 equal to 3 plus 2, which is 5. So the first value of x is positive 5. So let us solve for the second value of x. So we have here x sub 2 minus 2 equal to, this time we use negative 3. So following again the process, eliminate negative 2. So we need to add 2 both sides of the equation. Negative 2 plus 2 here is now 0. So this will become x squared. And then you use the property or the rules in combining integers. Negative 3 plus 2 here, since they have different sign, you subtract. So 3 minus 2 is 1. And then you copy the sign of the larger number, which is 3. So the sign of the larger number is negative. So the answer is negative 1. Therefore, the solutions for the given, let's go back to the given. From the given equation, quantity x minus 2 quantity squared minus 9 equal to 0 is positive 5 and negative 1. So let us now check if positive 5 and negative 1 are correct solutions by checking. Again, in checking, we're going to use the original equation, the quantity x minus 2 quantity squared minus 9 equal to 0. So we will check if it satisfies the equation with x equal to 5 and x equal to negative 1. So let us substitute 5 for the equation. So we're just going to make x here as 5. So again, substitute 5. 5 copy minus 2 quantity squared copy again minus 9 equal to 0. So we'll deal first with the expression inside the parentheses. 5 minus 2 is 3 quantity squared minus 9 equal to 0. So this time you simplify. 3 times 3 here is 9 minus 9 equal to 0. So 9 minus 9 is 0 equal to 0. So therefore positive 5 satisfies the given equation quantity x minus 2 quantity squared minus 9 equal to 0. So let us check the other solution, which is x equal to negative 1. So this time we're going to substitute negative 1 for x. So this will become negative 1 for x, copy minus 2, copy quantity squared, copy minus 9 equal to 0. So deal first with the expression inside the parentheses, negative 1 minus 2. So since they have same sign, we add. So 1 plus 2 is 3. And then you copy their common sign. So we have negative 3 quantity squared minus 9 equal to 0. So we simplify again the expression with exponent, and that is negative 3 times negative 3, which is equal to positive 9. And then you copy minus 9 equal to 0. So we have here now 0 equal to 0. So therefore, x is equal to negative 1 is also a solution. And x equal to 5 satisfies the given equation together with x equal to negative 1. Okay? So let's have another similar example. For example number 5. Find the solutions of the quadratic equation quantity x plus 5 quantity squared minus 49 equal to 0. Again, we write the equation in the form x squared equal to k. So we need to eliminate first negative 49. So to do that, we add 49 in the both sides of the equation. You copy the other terms. Quantity x plus 5 quantity squared, you copy minus 49, and then you add 49. Since again, this is an equality, you add 49 also on the other side. That's why it became 0 plus 49. So this negative 49 plus 49 here will become now 0. So the remaining term or the remaining expression is now only quantity x plus 5 quantity squared equal to 49. So this condition is now in the form x squared equal to k, which is x plus 5 will stand for x. So we are now ready to extract. So we get the square root of both sides of the equation. That is the square root of quantity x plus 5 quantity squared equal to the square root of 49. So the square root of x plus 5 quantity squared, again, we just need to eliminate the parentheses and the exponent. So the remaining term or the remaining expression is x plus 5 equal to, you get the square root of 49, which is positive and negative 7. Again, we will solve this separately using positive 7 and negative 7. So we have here the first value of x plus 5 equal to, using positive 7 first. And then the other value of x, x squared, copy plus 5 equal to, this time we're going to use negative 7. So we're going to solve these two linear equations separately here. Okay, going back, x sub 1 plus 5 equal to 7, and x sub 2 plus 5 equal to negative 7. Again, isolate x sub 1 by making this term 0. So since this is positive 5, we subtract 5. So that is x sub 1 plus 5 minus 5, again, equal to 7. Subtract also negative 5, subtract also 5 on the other side of the equation. So 7 minus 5. And then we simplify 5 minus 5 is now 0. You will have x sub 1. And then 7 minus 5 is positive 2. So the first solution for the given is positive 2. Next, we have x squared plus 5 equal to negative 7. So we need to eliminate 5 here. So we have to subtract 5 in both sides of the equation. That is x squared copy plus 5 and then subtract 5 equal to negative 7, subtract 5 also. So positive 5 minus 5 is now 0. So matitira is x squared equal to negative 7 minus 5. So they have the same sign. So following the rules of combining integers, we add 7 plus 5. So that is 12. And then you copy their common signs, negative. So the second value of x here is negative 12. So now let us check if positive 2 and negative 12 satisfies the given equation by quantity x plus 5 squared minus 49 equal to 0. So the computed roots are positive 2 and negative 12. So let us first substitute positive 2 here on the original equation. So this will become 2, quantity 2 plus copy 5, quantity squared, copy minus 49 equal to 0. So let's deal first with the expression inside the parentheses, that is 2 plus 5, which is 7. Quantity squared, copy minus 49 equal to 0. So 7 squared is 7 times 7, which is now 49 minus 49 equal to 0. So 49 minus 49 is 0 equal to 0. So therefore, it satisfies the equation. Next, let's use negative 12. So let us substitute negative 12 for x. So this will become quantity negative 12. So your x now became negative 12 plus 5 quantity squared minus 49 equal to 0. So deal first with the expression inside the parentheses. Negative 12 plus 5 is negative 7 since they have different signs. So we subtract 12 minus 5 is 7 and then use the sign of the larger integer which is 12. So we use negative. So that is negative 7 quantity squared. You copy minus 49 equal to 0. So negative 7 times negative 7 here now is positive 49 minus 49 equal to 0. So 49 minus 49 is 0 equal to 0. So therefore, x is equal to 2 satisfies the given equation. Also, x equal to negative 12 satisfies the given equation. So that's it. Those are the different conditions for the quadratic equation in the form x squared equal to k. So there are differences in dealing with different conditions. Okay, so let us now practice your skills from example 1 to 5 by answering our fast hand exercise. So again, I will give you 5 items for you to answer in 10 minutes. So get your pen and paper now to solve for this, and later you're going to write your scores on the comment section of this video. So you're going to solve the following quadratic equations by extracting the square root. So these examples are similar to those examples that we have discussed a while ago. So for number 1, we have x squared minus 81 equal to 0. Number 2, we have 3x squared minus 27 equal to 0. Number 3, we have 2x squared minus 98 equal to 0. Number 4, we have quantity x minus 3 quantity squared minus 64 equal to 0. And then number 5, we have quantity x plus 2 quantity squared minus 1 equal to 0. So let us try if you can solve this quadratic equation using extracting the square root. Okay? Are you ready? Your time starts now. have 4 minutes. Last 30 seconds. Okay, that's it. Okay, so this time we're now going to check your work. Okay, here are the answers. So you could have 2 points for each item. For number 1, we have x equal to positive and negative 9. Okay, check your work. For number 2, given 3x squared minus 27 equal to 0, we have x equal to positive and negative 3. Then for number 3, we have 2x squared minus 98 equal to 0. The solutions are positive and negative 7. For number 4, we have quantity x minus 3 quantity squared minus 64 equal to 0. the solutions are positive 11 and negative 5. For number 5, we have quantity x plus 2, quantity squared, minus 1 equal to 0. Our solutions are negative 1 and negative 3. So again, I'll give you 30 seconds to check your answers, and then after that you put or write type the scores on the comment section of this video. Okay, so thank you for participating for the fast hand exercise. So again, of course, since already finished this video lesson for lesson number 2, solving quadratic equation by subtracting the square root. Again, we have a home task that we're going to check on the next video lesson that I'm going to upload. So in your home task, you will just do what you did from the fast hand exercise. So again, you're going to solve the following quadratic equation by extracting the square. So you are now free to copy the given, and then you answer this for 1 week, and then after next Monday, we're going to check this home task before we start the next video lesson. Again, thank you for listening, thank you for watching, thank you for subscribing. This is my second video now. Keep on subscribing, keep on watching, and keep on learning. No? So still copying the home task. Last 1 minute so that we can have our goodbye for this video lesson. Okay, so good luck on your home task. Please answer your home task because we're going to check your home task on my next video lesson. So we're done. We're all done. Thank you for watching and participating. See you on my next video lesson. Again, this is Sir Phil on your Sir Phil's channel.